Good morning. Today is February 24th, 2018, and this is the John Chappell Natural Philosophy Society Science Chat. And we welcome you to support our mission by becoming a member. We can be found at naturalphilosophy.org. And we're also on Facebook. So, Harry, we were discussing some of the email messages going across, and we're trying to figure out what the problem is and what they're trying to discuss here. So for those who don't follow along, there's a very large email chain that goes out to about 50 people. And this was kind of started out by Glenn Baxter, who passed away not too long ago, but it continues on. So this email was kind of his legacy. And
part of it has to do with Ron Hatch, who has this theory. And from what I understand, Ron Hatch's idea is that height contraction and time dilation explain why the revolution around the sun, the Earth revolves around the sun at 30 kilometers per second. Okay, and that does not show up in any experiments. It doesn't show up in the GPS, and it doesn't show up in any earthbound experiments, which is the reason why supposedly Einstein invented relativity, but that in and of itself is another point of confusion. But Ron's theory seems to be something along the order of that he uses length contraction and time dilation of clocks to explain why it's not detectable in GPS. And they seem to be talking about it, but about Ron's theory, but it doesn't, it's so confused and discussion is so terminologically faulty that you can't really follow what they're saying.
Yeah, well, there's just so much volume in the emails going back and forth that I tend to just click right through them because I don't really have time to read the 23 emails they're sending out per day on this topic. So I was kind of hoping whether you could help summarize what they're trying to say, because this comes up every once in a while. And the geocentrists usually add their little bit onto this, and Ron adds his little bit onto this.
Well, Ron has this theory that he claims that he can explain why the GPS doesn't include the 30 kilometer per second motion around the sun. None of the experiments that have ever been done, okay, and if you want to see the review of the experiments, there's a very good review of them that's done by Robert Sanjonas film, Galileo Was Wrong. And he talks about all the experiments, goes back to the first experiment that was done by, I forget who it was, and he examined the spectrum of a star, looked at a star, and supposedly, if the Earth was moving, that star should have been shifting its position, but it didn't. And that was like in 1820 or something like that. So these experiments, have been conducted for a long time, and they never proved or demonstrated any motion of the Earth around the sun with respect to measurement performed by the speed of light. And so this has been a problem for quite a long time. And mainstream says that Einstein solved it with special relativity theory, which claims the speed of light's a constant. But that just creates more confusion and doesn't really solve the problem. And does that help you any?
Well, what is Ron's explanation for why we cannot measure the 30 kilometer per second speed?
He says that the clocks change and length contracts such that we can't detect the motion of the Earth around the sun in the GPS system. That's my understanding of it. If somebody has a better understanding of it, I'd appreciate hearing about it. But I've read his papers, and I have a lot of difficulty following it.
So that is a length contraction argument rather than it's not there. So what his attitude would be is that the Earth really does move at 30 kilometers per second. It's just that the clocks are shortened in the direction of travel such that it doesn't look like there's a change in time.
Well, yeah, that's sort of basically it. And then this guy, Doug Moret, sort of has a similar type of idea, but he falls back on the traditional Lorentz contraction idea. The traditional length contraction idea was Fitzgerald, who is a Maxwellian theorist in the late 19th century, suggested that the reason the experiments of Michelson didn't detect any motion around the sun. Now, just to make this a little clearer, John Clerk Maxwell originally suggested this idea. He said that it should be that the motion of the sun around the Earth would be detectable in an experiment by measuring the speed of light. And then Michelson tried to do it and couldn't detect the speed, any interference shift due to the velocity of the Earth going around the sun. And he kept making his experiment more and more sensitive and couldn't detect any such speed in any of his experiments using the technique that he was using. And then that led to them doing more experiments where they raised the device up above and they put it on mountaintops, because the idea was that the ether was stagnant near the surface of the Earth because it was entrained by the gravity of the Earth. And so the idea was that if you raise the device further up, it would be more detectable. And of course, Dayton Miller claimed to have detected that. And so that's where this Dayton Miller controversy comes from, because he claimed that by putting this interferometer on the top of Mount Palomar or Mount Wilson, I forget which one it was, that they detected an effect. But by that time, relativity had been pretty well established. And of course, the mainstream experts said that no, he didn't detect any such fringe shift at all, and that was all just due to experimental errors. So I guess I'm leading the discussion astray. Do you follow what's going on so far? This is all reviewed classical, what you read in the books.
Well, what do you think of that? I mean, did Dayton Miller measure anything, or was it in fact experimental error? Did he have a point?
I don't know that anybody knows. None of the experiments have ever been able to detect it. Okay, so since you can't detect the motion of the Earth around the sun by any experiment, then, since mainstream says that the Earth revolves around the sun, or revolves is the correct term, not rotate. Rotate is the body which rotates on its own axis. Revolving is what planets do. That's not detectable in any experiment. So Einstein's claim to fame was he claimed his theory explained it and removed that difficulty from science. So mainstream's sort of forced to if they don't maintain the relativity theory, then they've got this problem of how to explain why they can't detect the motion of the revolution of the Earth around the sun. So they're trapped in a problem there. So their solution is to maintain that relativity is correct, and that resolves the problem.
I don't know if you guys know of, I'm sure you do, Reginald Cahill, I think down in Australia. He has many papers and has performed experiments and is able, yes, to measure light speed and isotropy. So the speed of light is different in different directions, and explains why Michelson-Morley's experiment does not detect that, as well as other things. He has papers on how to measure the one-way speed of light versus the two-way. Two-way, of course, if it slows down and going one way and it'd speed up going the other way, the average cancels out and you wouldn't measure any anisotropy. So it looks like there are experiments now, not just one or two, but many that could qualify that, could be measuring the speed of light, has different values in different directions.
Well, okay. So here's the Ron Hatch has a theory, okay, and that's what the topic was that came up, okay. There's the problem is there's a lot of theories, and as you mentioned, Reg Cahill has a theory, Ron Hatch has a theory. All these people, there's lots of people who have theories. The issue is because mainstream has resolved this problem to their satisfaction, they have no reason to pay attention to any of these alternative theories.
Although Cahill is reporting on experimental results, but you're absolutely right. Mainstream science is still not paying attention, very dismissive.
So the real issue had to do with Ron. What I said, I made a comment about Doug Merritt has this theory. He's sort of maintaining the traditional Lorentz contraction idea, which is that the instrument dimensions shrink in the direction of the motion, which was the proposal by Fitzgerald. And that compensates for the time differential that is expected to be measured. The problem with that is that Kennedy and Thorndike did this experiment in which they claim that they removed the length contraction effect from the experiment, and so therefore they say that the physical length contraction of the experiment could not be an explanation for the result of the experiment, and that supported the special relativity theory, and so that meant that Einstein was right. But then that leads into the whole thing is just basically just a lot of confusion. That's really the summary of the story.
Well, I think that's interesting that you pointed out there's an experiment to show that the length contraction actually doesn't happen, right? I mean,
and then there got to be a dispute about that. See, Ron disputed that. He said because Ron has this theory that length contraction explains the GPS. He got all upset over that, and accused me of saying things I didn't say. All I really said was that there's a controversy about whether or not this is an explanation or not, and there's this different opinions by these different experts that say yes and no, and that doesn't seem to be resolved. Mainstream sort of resolves it by saying that Einstein's right and just basically kind of ignoring any of the arguments by these people who are disputing. Do you understand what I'm saying?
Yeah, you just throw in the Einstein card.
Well, it's too complicated for most people to figure out, so they...
Yeah, it's so complicated, you just throw in the Einstein card, says Einstein said this, and then everyone goes, oh, and then they stop thinking about it. Even though Einstein may not even have said such a thing, but that's why I call throwing the Einstein card.
Well, yeah, that's why I sort of went to the solution of saying, and Stephen Carruthers has sort of followed along in this direction of saying that you can't really, to argue whether relativity is true or false on the basis of experiments is too confusing and too wrapped in obscurity and contradictory interpretations to really make any sense out of it. And it's just Einstein's relativity theory can be easily dismissed on the basis that its foundation is illogical and contradictory. And that's the best way to go about getting rid of it is to show that it's mathematically fallacious. And of course, Dingle did that, and they ignored that as well. So, you just really, the only way that I see that you can get rid of it is to just basically point out that it's illogical and mathematically fallacious.
Well, I wanted to get back to this Fitzgerald contraction thing. Now, me personally, I see no reason why any object should contract in the direction that it's traveling. I mean, in order to make that kind of theory plausible, I think you would at least have to provide some reason why some object should contract upon acceleration. And I've just never heard of anything like that. It just seems to me that this Fitzgerald contraction hypothesis was put forth as an ad hoc band-aid to the MMX experiment. I mean, you just can't. I mean, you can explain the MMX if, you got this kind of Fitzgerald contraction, but why would there be such a logically? Why should there be such a contraction? I don't see that. So that makes me highly skeptical about this idea that things can contract. I mean, that's also part of relativity, where they also predict that same kind of thing. Once again, theoretically, if a spaceship got too close to the speed of light, it would be like as flat as a pancake. And I find that hard to believe. And I don't think that I've seen any convincing experimental evidence really to that effect. I mean, I think they've been trying to do that in particle accelerators to show that the shape of the particles must actually become this disk-like thing. But it just hasn't been very convincing that this kind of thing happens.
I think the problem is that the entrained ether people didn't go far enough away from the surface of the Earth.
Yeah, that's the other solution. I suppose if I were to try to explain, why is it we cannot measure the 30 kilometer per second speed in the Earth is because
Actually, it does show up with interplanetary space probes.
Does it? Have they done that experiment yet?
They use it all the time, and just communicating with Mars spacecraft. They have to use the sun-centered inertial frame to get their calculations right. They call it the SBB, or solar barycentric.
Barycentric.
SBC, right?
What did they call it? What did they call it so we can look it up?
I think it's solar barycentric inertial frame or something like that. But
so which frame is that? Is that the frame that assumes that everything is stationary in the sun?
No. This is the local ether idea that each astronomically sized body has a sphere of ether around it associated with its gravitational potential. Remember the talk I gave a couple of weeks ago about Ching-Chuan Tzu's papers?
So was he talking about? But did do they have experiments proving that there is such a bubble around each planet?
If you assume that, then all the measurements that are done are consistent with it. Not that there's been a specific experiment done to prove or disprove it, but that would make the bubble extend out to as much as 1 million kilometers from the surface of the Earth. That would explain.
Well, I mean, I'm intrigued by the possibility. You know, we've got like satellites going around Mars, and certainly those would be affected by any such entrained bubble, and they're communicating with us all the time. We also have space probes that go, like, say, flying past Uranus, and certainly while they're exiting the gravitational influence of that planet, you think that that would affect the transmission times. And I know that they keep very, very close track of the transmissions, the Doppler effects, and you would think that...
It works out with C.C. Su's papers. And I think that's where all the dissidents have gone off in the wrong direction by trying to fight for the Lorentzian ether. I mean, that's Ron Hatch's idea, although he calls it modified Lorentzian because he has to account for the speed of light changes due to gravitational potential, which Lorentz hadn't put into his original Lorentzian ether idea. But you really need to go back to the entrained ether if you're going to find a different path, I think.
But what you're saying is that Ron Hatch is a heliocentrist.
No, I'm saying he's a Lorentz ether guy.
Which is a heliocentric ether. Wait a minute, the Lorentzian ether is heliocentric, right?
I don't think so. It's universal. It's the same ether throughout the universe.
I don't know that Lorentz said that, but
yeah, that was the whole idea back then.
Where did he say that?
Was the whole idea of most of the ether mainstream before Einstein was that it was static.
It was a heliocentric ether.
No, not heliocentric. They didn't. It was all the whole universe was one static ether that everything moved relative to.
Well, I think your terminology is confusing.
Well, all right. So
you're talking about the universal stationary ether that the MMX was trying to detect, right? Because if the ether was just this giant sea that all the planets flowed through, and it was stationary, then we should be able to detect the speed, the absolute speed of the Earth, through that ether, which is the same everywhere. So that's one way of looking at it, right? So, Jim, that's what you're talking about, the universal same ether everywhere?
Right. That's Lorentz's, and like I said, most of the mainstream pre-Einstein ether approaches were.
But now the entrained ether is different than that. So in addition to there may still be a universal ether sea, but around each individual planet, it would entrain its own little bubble of ether, right? Now, I'm not sure what to call that.
Not that it's little, but and now specifically with SU, it's associated with the gravitational potential or gravitation or even the field, where the field switches from the boundary would be where the field switches from pointing towards the object to pointing towards some other object, like the sun.
Right, directly associated with the gravitational potential. So at some point, the gravity is either attracted towards the Earth or attracted towards something else.
The gravitational field is the gradient of the gravitational potential. That's the field is in other words, the force is the gradient. It's the vector, where the vector points, essentially.
So do you feel it's far more probable that we have a universe where we have this entrained ether?
Yes, I think that's that explains the GPS.
I don't think the word entrained is proper, but
Sorry?
well, you see, now you're back to this terminology issue, and most people get hung up over the terminology.
Well, yeah, I mean, I mean, Stokes tried to.
Well, let's be a little bit clear about this. I look at it this way. I say that in the 19th century, there were two theories. There was the Stokes entrained ether theory, and there was the Fresnel universal ether theory, which in the 19th century was a heliocentric theory because they didn't really have much of a conception beyond the solar system. Okay, so you had a ether at rest with respect to the sun, which is the Fresnel ether theory, and then you have an ether entrained with respect to the Earth, which is the Stokes theory. But those ethers were physical ether. There was some kind of a physical thing. Okay.
Well, what's the matter with that?
I'm not saying there's anything wrong with it. I'm just saying that that's the concept that they were using.
Well, yeah, I'm cool with a physical ether. I love a physical ether.
Well, now, but the gravitational ether that he was just talking about was an idea introduced by Peter Beckmann, and Beckmann didn't really say that it was physical, as I understand it, but I could be wrong about that.
Well,
and it was more of a gravitational field defined the speed of light.
They didn't want to try to say what the physical or not properties. They just want to say, if you assume that the boundaries are like this, and that the speed of light is proportional to the density of the strength of the gravitational potential, that everything works. So first you have to prove that works, and that it works better than Einstein. Then you can start to talk about what it's made of and what its properties are and what its dynamics are.
I don't know that it works better than Einstein. I don't know how you do that.
Well, what about the Sagnac effect in GPS? That's not well explained by mainstream. Certainly a lot simpler if you assume an ECI stationary ether.
Yeah, I think experimentally, the experiments say that we really can't readily detect 30 kilometers per second around the sun. However, using Sagnac, we can detect the 24-hour rotation of the Earth. So the 24-hour rotation of the Earth is detectable. That is a clear experimental result.
And that's a direct contradiction or falsification of relativity, I'd say. Special relativity in particular. The only way they can try to explain it with Ashby, they start going with tensors, and they have to invoke general relativity. But general relativity is based on special relativity. So you can't prove a theory that contradicts the basis of. You can't prove an experiment or an observation based on a theory that's built on something that is contradicted, in my opinion.
I think if you're going to say stuff like that, that's like saying something like, this contradicts quantum physics, which could be like anything. So do you have a specific thing in relativity that contradicts? I mean, we have the formula of relativity is basically what we have, right?
Well, here's the deal. Special relativity says that the speed of light is constant in an inertial frame, okay, and any other inertial frame moving relatively to the observer's inertial frame. So pick an inertial frame. The speed of light is c in that frame, and it's also c in any other inertial frame moving relatively to that frame. And so in all inertial frames, the velocity of light is c. The problem with that theory is that there's no real inertial frame that you can do an experiment in. So Sagnac did an experiment where he took a rotating table and he showed that the speed of light was not the same depending upon the direction of rotation. So that when he measured the speed of light, he showed there was a fringe shift. So the speed of light going around the table when the table was spinning was different than when the speed of light going around the table was at rest. And that made absolutely no impression upon the relativists. They basically said, well, that's not an inertial frame. And then, of course, over time, they came up with these explanations that they could explain that result, and it was fully consistent with general relativity. So it had nothing to do with refuting special relativity or general relativity, and it was completely explainable within the theory. That shows the weakness of these experiments, okay, because for every experiment that you do, you claim to refute general or special relativity. They can come up with a way of figuring out how they can explain it in terms of their theory, because their theory is so flexible and you can make lots of assumptions and then figure out a way to make it look like it meets the requirement. So experiments haven't really been very successful in refuting special relativity or general relativity because you're dealing with something that's not very well defined. And that goes into what Roger Anderton says, which is there's all these different interpretations of special relativity and different textbooks say different things. And when you get into an argument with these people, everybody has a different understanding of what he thinks it means and sticks to that. And if he believes that, special relativity in general is correct, then, there's no way you can convince them otherwise. So, it's just kind of a fruitless struggle, in my opinion.
Yeah, that's why I try to stay away too much from vague discussions about special and general relativity, do this or that. I mean, I would be more interested in just looking at the experimental results. The two primary experimental results is that there is no detection of the 30-kilometer orbital speed of the Earth, but there is a detection of the 24-hour rotation of the Earth. So how do we come up with theories that explain that? So, Jim has given us like the various ether possibilities. One ether possibility is that there's a universal ether that exists the same everywhere. So using that was a theory that Michelson Morley used, and they figured they could detect the 30-kilometer speed of the Earth as it orbits, but they did not. So I think we would have to conclude that this universal ether theory is incorrect. So what are the alternatives? So you have like Stokes' theory of a material entrained ether. I think me and Jim like that theory better. But in that theory, we would have to explain why is it we can detect the 24-hour rotation. We can explain pretty easily why we don't pick up the 30 kilometers per hour, because if we're in our bubble of ether that's moving with the surface of the Earth, then we would expect that the ether is in fact stationary to the surface of the Earth, and therefore we really can't detect that. So we don't see the 30 kilometers.
No, both Beckman and Sue are also saying that the ether entrained by the Earth does not rotate with the Earth. It's fixed in direction to the fixed stars. So that there is.
Yeah. So that's kind of the point I'm getting to. That if we thought it was fixed to the center of the Earth, then that would contradict the Sagnac result, because if it was totally fixed to the Earth, and say the geocentrists believe this, they believe that the Earth is the absolute center of the universe. It doesn't rotate at all, so the ether, if it exists, is in fact affixed to the surface of the Earth. But that would contradict the Sagnac experiment, and it would contradict, like they have this big Foucault
Well,
pendulum.
let's get our terminology correct. It's not the Sagnac experiment, it's the Michelson-Gale experiment.
And also GPS.
Yes, it's also GPS. So
okay, now let's I see there's a point of confusion here. The Sagnac experiment is an experiment in which a series of mirrors are placed on a platform, and there's some kind of a light beam that's on the platform, and the light is caused to go around the circumference of the platform to a photographic device, or some, I think it's a photographic device. And then what happens is when the platform's at rest, you can set the beams of light going in one direction and another beam of light going around the circumference in another direction, and they can interfere and create a null. And then when you spin the platform, the null is shifted. You don't get a null, you get a fringe shift. So that says that the speed of light on the platform going in the two different circumferential directions is not the same. Okay, that's the Sagnac experiment. You understand that?
yeah, I think you may be right. I mean that it's the Michelson-Gale one, which
okay,
which
now
I think
that
established a
experiment
24-hour rotation.
right. That experiment was done prior to the First World War, as I recall, between 1910 and the beginning of the First World War, somewhere in that time frame. And there's a guy named Harras is also, his name's associated with that. And I think that Sagnac did one, and this Harras guy did another similar type experiment. But the other guy, the Harras or whatever his name is, his name sort of got dropped, and the Sagnac name has been associated with it, and some people call it the Sagnac effect. Okay, when they're talking about GPS, they're talking about the Sagnac effect, which is that the speed of light, okay, if you send a satellite signal up to a geosynchronous satellite and down to the Earth, and you do that, and you bounce up and down through these geosynchronous satellites, and you go around the Earth in the westerly direction, and you go around the Earth in the easterly direction, you find that the time delay for the signal, assuming that you compensate for all the delays going through the satellites, okay, is different. So the time to go around the Earth in the east direction is different from the time to go around in the west direction, and that's called the Sagnac effect. Okay.
Actually, it's better than that, because they've also found that if you send light or a radio signal in one direction from New York to San Francisco, and then San Francisco sends a signal back to New York, that the amount of time it takes is different by the factor of the velocity of rotation of the Earth at that point, at that latitude.
Right. Well, but this is the point. This has been done for quite a long time.
The point being that relativity can try to throw out the around the world effect, because it's a rotation. There's a circle, but this two-way measurement is one way. What does not involve a rotation.
Well, anyway, basically, the bottom line is that the effect is referred to as the Sagnac effect if it involves rotation. In the case of GPS, they refer to it as the Sagnac effect or the Sagnac compensation because of the rotation of the
Earth. And it's a misnomer to try to distract from the fact that it's a direct refutation of this constant velocity of light. Because it happens in a one-way situation, and there's no acceleration.
You got this now, Franklin?
Well, the picture...
You got to be a little bit careful about the words that you use, because as soon as you start using confusing different terminology, then the whole thing becomes obscured, what you're talking about. And you'll notice that in these email discussions, people insist upon using different terminology so that that keeps the understanding confused.
Well, then we should just not use any terms and just explain explicitly what we're talking about. So, for example, what I would be explicitly talking about, that the only kind of ether that would be consistent with what we're talking about would be there's like a shell of stationary ether around the Earth, but that shell is affixed to the stars. That's the specific concept that you have.
It's not. I mean, the direction of it or the movement.
Yeah.
Of it doesn't.
The movement of it, direction of it, it's basically affixed to the stars. So if you have like the North Star up there and there's another star in the south and one in the east, the ether that the Earth is in has got to remain basically experimentally stationary to the universe of stars around us.
In terms of rotation.
Yes, in terms of rotation.
It's called the Earth-centered inertial frame, ECI.
Yes, that is the Earth-centered inertial, the ECI, which is Earth-centered inertial frame. Now, in my discussions with Ronald Hatch, who's the biggest expert on GPS, that is the frame that GPS uses. So GPS assumes that the surface of the Earth is rotating underneath the GPS satellites, but that the satellites are orbiting relative to a point which is just in the center of the Earth. So that's a little bit confusing about what that means.
The ECI is defined to the center of the Earth. So they're just saying they're moving within the ECI, relative to the ECI.
Yeah, so if you went, and we would have to add that, like, if there was like a little golf ball in the center of the Earth, and we painted a north, south, east, and west, and around it.
Okay, let me sort of clarify a little bit here. The ECI is the frame in which the satellite orbit calculations are basically simple. They take their simplest form in the ECI frame. That's basically the whole point there. Okay. And in the ECI frame, once you launch the satellite up, okay, what governs the orbit of the satellite primarily is the gravitational field of the Earth. The gravitational field of the Earth doesn't revolve with the Earth. So the satellites don't revolve with the revolution of the Earth. They remain in what's called the ECI frame. Does that make sense to you?
Yeah, I think you can see that, like when they launch a satellite off the Earth, it literally turns.
Now you got to be
right.
A little careful about this, because geosynchronous satellites do revolve with the revolution of the Earth. So they're basically pretty much, they're not exactly fixed with respect to the ECI frame. They kind of move around in what's called a figure-8 pattern. But as the Earth revolves, the satellites pretty much stay in the same position.
That's
okay.
They're orbiting at the same speed as the Earth revolves. And
correct.
So they're still moving through the ECI as if they were a regular satellite. It's just that.
Right, but you got to be careful in realizing that this is a function of how the orbits are designed. Okay, how the orbits are designed. The GPS satellites use these polar orbits. They orbit in the plane that's perpendicular to the equator.
No, they're at 55 degrees inclination, I believe.
Well, whatever, but they're not in the plane of the equator.
Well, I think it might be helpful to see, like, if you were to launch a spaceship straight up, we're not orbiting, just straight up from the surface of the Earth, then what do you think, like a day later, where the launch point would be relative to where the spaceship is.
The Earth is moving.
Yes. So if you launch the satellite out of Florida, then like 3 hours later, what part of the Earth would be facing the spaceship? Would it be Florida?
Depends on what the velocity vector is of the spaceship.
Well, the velocity vector is straight up tangential to the Earth.
All right. Well, I think we're getting into an area that's really not really relevant to the discussion.
Well, it is relevant because what's going to happen?
It's relevant to the discussion.
Because what's going to happen is that because the Earth rotates, does have a genuine rotation, that once it leaves Florida, the Earth is going to rotate, and pretty soon it's going to be on the. It's going to be like in Africa. It's going to be over Africa, and then eventually it's going to be over China, and then eventually it's going to be, because the Earth keeps on rotating, even though, because once you send the rocket ship out, it's no longer attached to the surface of the Earth. It's an inertial frame.
I don't know.
So
when you use that word inertial frame, now you're creating a lot of problems. There's no such thing as inertial frame as far as I know.
That if you're talking about the ECI-centered inertial frame.
Which is a fiction, remember.
Well, no, actually, I don't believe it's a fiction. I think for those of us who believe in an entrained ether, that we think that thing is real.
All right.
And that the Earth rotates inside that inertial frame.
Well, when you launch a satellite, it's initially got the velocity in the direction of the Earth's rotation because it's fixed. It's sitting on the Earth, so it's even though once you launch it, it isn't being rotated with the Earth. It's initially going to have the same velocity in the Earth's direction. Rotation.
Well, that's true. That's true. I mean, so it's not quite as simple as that.
It's not an inertial frame because the Earth has a gravitational field. Okay. So it's not, the satellite doesn't move inertially. It's moving in a gravitational field.
Well, that's another complication.
So it's not actually an inertial frame.
But if you get to that point, then yes, you could say there are no inertial frames, but you could say things are inertial enough that you can talk about them.
Well, you see, it's kind of a terminology issue of what you're talking about and what you mean when you say that. They essentially, I'm not exactly sure what they mean. What they mean is the ECI is an inertial frame that they imagine to exist mathematically. Okay. So we imagine that this frame exists. Okay, and it has these axes that are fixed with respect to the stars. Okay, and then you say, oh, let's put a gravitational field at the center of this inertial frame, and we'll say that represents the gravity of the Earth, the gravity field of the Earth. And so now you have an inertial frame with a gravity field put into it. Does that make sense to you?
It does, but I'm not sure whether the gravity field is particularly relevant to try and figure out why is it.
You have to have that to calculate the orbit of a satellite.
Well, we're not really. I mean, the two pieces of data we're trying to really account for is A, there's a 30-kilometer orbital motion of the Earth, which we cannot detect, and B, there's a 24-hour rotation.
The ECI frame, the center of the ECI frame, presumably has to be revolving around the sun.
Yeah, it's entrained with the sun, but you'd have to go out possibly as far as 1 million miles from the center of the Earth to get out of it.
Okay, so basically the bottom line is that when we do these satellite orbit calculations, the primary calculation is based on the gravitational field of the Earth, and we have this ECI frame, which is fixed to the Earth. And then you can calculate as a first approximation the satellite orbits within this frame, this ECI frame, which is taken to be an inertial frame with the gravitational field of the Earth, where you take the gravity field and you assume that the gravity is due to a point source at the origin of the frame, okay? And that's your first approximation to the calculation of the orbits. Is this not correct?
Well, I think this is where usually the geocentrists usually hop in, because basically you have to account for this thing that the frame is affixed to the stars. So, you know, that's kind of a tricky thing. It's like, why would the frame be affixed to the stars? One way to think about it that the geocentrists would love is that the Earth is in fact the center of the universe, and that's why our ECI frame is fixed to the center of the stars, because we're the center of the universe. So that's one way to explain that little bit of experimental fact, which is that you can just pretend that the Earth is in fact the center of the universe, that all of the so-called ether is surrounding the Earth and it's fixed to that frame, but that the Earth is rotating within that frame. Although I think some of the geocentrists would deny that part, but I would think that that is one way to look at it, which is that there is this universal ether, but unfortunately it would actually have to be, you know, affixed to the ECI, which is the one thing the non-geocentrists don't like to admit. But otherwise explains,
Well, Franklin,
you know, why we can detect the 24-hour rotation, and it says that explains why we don't get the 30 kilometers rotation. But it does seem a little far-fetched.
You're getting a lot of other stuff confused. Okay, you don't seem to. I don't know. I have to go here in a few minutes. I'm not really sure exactly how to, you know, disabuse you of a lot of false ideas that you have. But I mean, I think you're just making it more complicated than you need to. Have you read any books on, you know, orbital mechanics or anything like that? I mean, this whole thing is getting really messed up. Okay.
Well, the thing is that I think your confusion is that you are trying to introduce orbital mechanics here. But
my confusion?
What we're talking about here is the apparent, you know, ability. Well, if you think there isn't ether, then you have to explain these experiments.
Well, if the Earth if there's an entrained bubble of ether around the Earth, then it's carrying it, and you're not going to see the 30 kilometers inside that bubble.
Yeah, but why would it be fixed?
That's why that hypothesis has been put forward.
Why would it be fixed to the sphere of the surrounding universe? Why would it be fixed to that?
Well, that's only the direction of it. The extent of it is only out to the edge of the bubble, and the transition zone.
Yes, but you would still have to explain why it's affixed to the universe, the galactic sphere.
Not for the whole universe. It's only for the bubble around the Earth.
Yes, and you would still. Do you understand that you should have some explanation for why it's affixed to
with the Earth?
Well, why should it be affixed to the spheres of the stars?
Not fixed. I mean,
there you go. This is Franklin.
Right. So let's just stipulate that that and see where it gets us. If we assume a sphere of ether around the Earth that does not rotate with the Earth.
Yeah, I totally agree with that. But there's still, but you still have to explain why what it's relative to.
Observations, okay.
I mean, I totally agree with that. It's like, there's a bubble of Earth around the ether, but, you know, for some reason, it, you know, not only does it not rotate with the Earth, but it appears to be affixed to the sphere of the stars.
Only in direction, not in extent.
And that doesn't matter. I mean, yeah, the direction. Why direction? Why that direction?
It doesn't matter for when you're near the Earth. Well, it does matter, actually, because, you know, it's just crazy to think that the ECI extends out. I mean, that the ether in the universe does not does not rotate with the Earth.
I mean, really, I think the one experiment which has been suggested, which would be good, was to just send out an MMX experiment out on a satellite and see what's out there.
Well, you don't even have to go that far. All you have to do is in low Earth orbit, because then in low Earth orbit, the satellite's moving at 7 kilometers a second, and that should be.
Now you have to get, if there's an entrainment, then at some point that the ether is not going to be entrained by the Earth. So, like, if we stuck an MMX experiment on with Tesla's Roadster that they just sent out to like Mars, then at some point we should be able to detect the full orbital speed of that Tesla around the sun.
Absolutely, but until you can convince the mainstream to try it, you got to try to do the simpler one, which is just low Earth orbit, where the satellite makes its own relative motion against the ECI of 7 kilometers a second, and that should be detectable by an interferometer. And now with CubeSats and the new company in New Zealand that's only charges about $100,000 to launch a CubeSat, you might actually be able to crowdfund it or something, not have to depend on approval by NASA.
Yep, so that's possible. So that could be a goal of us citizen scientists, which is to send up an MMX experiment up and make some predictions that totally contradict.
First of all, you got to get the mainstream to predict that you won't see anything. And
yeah, they're going to predict, get them to predict what it is, and then we'll make our predictions, and then the experiment will prove them wrong, and then they will ignore it.
Well, but at least maybe you can convince some other people that aren't so wedded to relativity that here's a direct refutation.
Uh-huh. That's kind of doubtful, seeing how not even SIGNET could do that. So that's a pretty obvious refutation. But
well, the other thing is that it would be, since it would be, so directly comparable to the MMX on Earth, it would be a lot more surprising.
It would be, but
I think it would be a lot more difficult to explain even with GR. And certainly GR would not predict the result.
Uh-huh. Well, me personally, I'm still sticking with there's a bubble of ether, stationary ether around the Earth. I still really can't explain why it's particularly affixed to the stars, but assuming that, then we can explain we can't see the 30 kilometers per second, although Dayton Miller did say he saw some, but it's not the full 30, because I think that there still may be a detectable ether wind, right? Even though we for the large part drag along our ether bubble, that we still get a detectable wind, headwind from our motion through around the sun. I mean, that's what Dayton Miller would tell you. Dayton Miller would tell you, yeah, we detected the motion of the Earth around the sun. It's just greatly reduced. And there's some reasons why that might be. But for the most part, I would say that the experimental result is due to the fact that there is the ether, it's a bubble of our ether, and we drag it around. But the Earth's surface is not attached to that, so we can see the rotation. So the surface of the Earth is in fact moving at, I don't know how many miles per hour it is. It's like 600 miles an hour or something.
It's 400 kilometers per second at typical 40 degrees latitude.
400? Well, that's not the rotational speed.
400 meters per second, I'm sorry.
40 meters per second. So
400 400 meters per second. About
400 meters per second.
4/10 of a kilometer per second.
That's still really fast. So me sitting here on my butt in Seattle, I just moved 400 kilometers, right?
It's virtually undetectable to an MMX experiment. Although
even though my butt just moves 400 kilometers in the last second, right? That's a lot of that's
not 400 kilometers, 4.400 kilometers, 4/10 of a kilometer per second.
okay. Well, that's a lot more reasonable because I didn't think I was moving that fast,
Right.
just to get around the Earth, right?
For the Earth's rotation on its axis.
Yes, the Earth rotation on its axis
at 40 degrees latitude.
Mm-hmm. Yeah, it's about where we are here in Seattle.
Right.
So it's 0.4 kilometers.
Exactly, right.
Which is not that fast.
And it's virtually undetectable by an MMX because it's a second order velocity.
But the other question is, if you're going to believe in that, then you have to kind of explain, well, why is it that there's this bubble around the Earth? I mean, what is it about the ether that allows it to gather around the Earth? You need to provide some kind of reason for that, right?
Well, if it's associated with the gravitational field, and that explains everything, you got to start there. Got to.
Well, why would it be associated with the gravitational field?
Make it a postulate and see how far it takes you.
No, I don't believe in that. It's like that is something that you should be able to explain, right?
As a first step.
Why should it be associated with the gravitational potential?
As a first step. Then if you can prove that with the MMX in orbit, or then you can start to ask what are its properties.
Well, your ether has properties, right? Now, what is your conception of the ether? What's it made out of? You definitely have an ether theory.
Yeah, well, I think I gave a presentation on the Tron theory fairly recently.
Yes, you did. So your Tron theory, if the ether is made out of your trons, then why should that be gravitationally entrained by the Earth?
Because it's the size of a tron, the density of a tron is proportional to the gravitational field. Well,
I mean, your main argument there is that a tron is made out of matter, and matter is gravitationally attracted. Or would you disagree with that statement?
The difference in the size of a tron, that one of the postulates is that the trons that they're. I'd have to go back to trying to explain the Tron theory again, but basically the attraction results from different sizes of trons trying to get larger, essentially, and that. But like I said, let's not try to go into the properties at this point. Let's just try to take it at the level of there's an ether, and then it's associated with it has a density that's proportional to the gravitational potential, and that the speed of light is proportional to the gravitational potential. And that's what Sue does, and shows that you can explain everything, and derive quantum mechanics as well.
Well, I take like a fairly simple approach. I mean, you're kind of stumbling over your words, and I'm just trying to figure out what that is. But in my view, for me, my ether is not made out of trons. My ether is made out of positrons and electron dipoles. So that's my conception of ether.
Isn't that Dirac's hypothesis at one point?
Well, Dirac's hypothesis was that, I don't know, he said like there's a sea of just like electrons, or a sea of like positrons.
Yeah, I think he had positrons in there too.
But no, that wasn't his, because it would be illogical for it to be only a sea of like one type of charge.
No, I think he had positrons too.
Really? No, I don't think so. I think that was what was wrong with his theory.
I haven't really studied it in detail, but it sounded to me very similar.
But in any case, my ether is positrons and electron dipoles, and in my conception of gravity is just an electrostatic force, it's just a very large positive charge, net charge on the Earth. And all dipoles, and actually all matter, basically point towards that charge source. And because of that, that's what actually causes the gravitational attraction. So these things being as dipoles would be under the gravitational attraction of the Earth. So if you make a whole ether out of dipoles and you put it in the electrostatic field, which is the Earth, then yes, you could see that they would all be attracted just like the atmosphere of the Earth, right? We know the atmosphere of the Earth made of mostly nitrogen and oxygen. That is definitely entrained as a bubble upon the Earth, right? And these ether particles, that's why I was trying to ask you whether you thought that the simplest explanation here is that, you know, the trons are made out of matter. Matter is attracted to the Earth, just like oxygen and nitrogen. And so naturally, one would think that it would form a bubble of that around the Earth. So I'm thinking that, yes, the ether forms a bubble around the Earth, much like the atmospheric envelope. And just like the atmospheric envelope, it gets, its density depends upon the gravitational gradient. And, you know, I think I did some research on this, which basically, you know, takes the time dilation, because there's a correction that for time according to the gravitational potential, right? And so the higher that you get up, the clocks run faster, that kind of thing. So that's an experimental result. And that's why I like to talk about experimental results, not talk about things like Einstein's general relativity, because that doesn't mean anything. But if you tell me that, you know, we have an experiment showing that clocks run slower as they are raised out of the gravitational field, that's something I can work with. But it turns out that if you plot, you know, that formula against the basically the atmospheric density, it ends up being about the same thing, which is what I would predict.
It actually varies as 1 over r, I believe, which is the same as the gravitational potential.
What? The gravitational potential is 1 over r squared.
No, that's the gravitational field. That's the gradient of the gravitational potential. You take the derivative of 1 over r, you get 1 over r squared.
No, I don't understand that. That's although I personally, well, the thing is that the atmospheric density, that's just a graph. That's just an experimental result. You have to actually look at the time dilation report. I'm a little bit vague on the details here.
Well, actually, there are two effects that GPS found. One is height, and the other is velocity. And Sue explains the velocity effect, the v squared over c squared velocity effect, as the increase of mass of the molecules in the atomic clock due to traveling against the ether of the field. But so actually, there are two effects you have to account for with GPS for the what's called clock bias, I guess. And the second one is the velocity effect is the one they say proves special relativity, but it doesn't, because it's constant with it doesn't, well, whatever, but it's also it doesn't depend on the orbital on height. It's in fact it affects even the clocks on the surface of the Earth, atomic clocks.
Yeah, well, once again, the two experimental effects you have to account for is the slowing of clocks in a high gravitational field, I think that's been well established. And so that's why I like to talk about that experimental result and not anything that has the word relativity in it. And then the other experimental result is that if you take a clock and you accelerate it, that clock also slows down.
It's not that you're accelerated. It's constant velocity.
Oh yeah, that's right. It's a velocity. The velocity, it's the clock is speed is in respect with the velocity.
With respect to the ECI in particular, only, and
yeah, I think that was what the contributional happy cading or whatever experiment showed when they sent the clocks in two directions on commercial jet airliners and found that the clock speed depended on which direction you were going, whether you were going with the Earth or against the Earth.
Which is also a contradiction to special relativity.
Yeah, although they made it sound like it confirmed special relativity because it confirms the formulas of the time contraction formulas.
I think they had to invoke GR to explain it.
That's why I like to say that. Forget about
also just the fact
relativity
that they have to use the ECI as a preferred frame is another refutation in my mind.
Yeah, the ECI is definitely a preferred frame. But I was just getting back to, I don't think you have to resort to this, let's just postulate everything kind of thing, because I can say that the reason why we have this entrained ether bubble is because my ether is made out of matter, which is gravitationally attracted. And therefore, one would exactly expect there to be an entrained bubble. Now, because all the rest of space is like filled with this stuff, I think you would have other effects, like there should be still some wind effects. It's like, what if its space was actually filled with nitrogen instead of being a vacuum? If the Earth was moving around that space, then ignoring frictional effects, it would still entrain a bubble of nitrogen around itself, but it would probably also still interact with the non-moving atmosphere of space.
But that's friction. That's exactly.
Well, that's why I would say you would have to ignore the effects of friction.
If no friction, then it would not rotate with the Earth. It would not be dragged with the Earth.
No, I think it would still be dragged with the Earth. If all of space were filled with was filled with a light nitrogen atmosphere,
it's dragging it. It eventually would slow down, right?
Well, that's why I said you'd have to ignore the effects of friction. So let's not throw that in there. If the Earth, let's not make the Earth rotate.
Friction, then there's no dragging. You need friction to drag.
No, we're not talking about drag. We're just talking about whether the Earth would entrain its own ball of nitrogen around itself.
But you were talking about whether it would rotate with the Earth too.
Well, that would be another question, because you would think that if there was a nitrogen space and the Earth would entrain its own little ball of nitrogen, that you'd think that the Earth's rotation would tend to drag the nitrogen ball with it. Or maybe it wouldn't. Maybe this is the reason why the ball is affixed to the stars, because it wants to stay stationary relative to the medium that it's going through. I mean, is that a reason?
I think.
Or what it could be is that
no friction. It's not going to rotate with the Earth. It's just going to maybe rotate with the sun, or maybe not even with the sun.
This is why I have to keep on getting you off of this whole friction thing.
That's what I mean by the direction fixed to the stars.
Yeah, but you keep on throwing in this friction thing, which I'm telling you have to ignore for the purposes of this discussion.
I'll ignore it for the purposes of dragging around the sun, but not for rotation, because you need a frictionless medium so that it doesn't rotate with the Earth.
Yeah, so I'm saying that this ether would be frictionless, but just to make the argument more concrete, put it in terms of things that we do know, which is the nitrogen atmosphere of the Earth, which I'm saying that basically the ether is exactly that. But instead of being made out of oxygen, it's made out of positron-electron dipoles. And that particular ether is friction-free, that things travel through that with no friction at all. Of course, that's the other problem people have with ethers, and that they don't believe that. They believe that if any ether is made out of matter, that everything will eventually be slowed down going through it.
That's one argument.
Yes. Although my argument against that is that the ether is actually the mechanism that mediates inertia, which is why objects keep on going at the same velocity. That's like the Newton's second law. Object in motion stays in motion. Why is that? Because it needs the ether in order to do that, because the ether is a thing which captures the kinetic energy of the object, stores it, and releases it back to the object as it travels at velocity. So rather than being a substance which gets in the way of a traveling object, that is the substance which actually allows an object to travel at stable velocities.
It's swimming in it, right?
Yes, it's swimming in it. It actually needs it in order to keep its forward movement. So that's kind of how I address that issue. So,
well,
see, did anyone else have any comments about this? This has all been kind of a how do we explain things with ether kind of discussion. Now, are there people who think we're totally crazy and that any discussion of the ether is completely insane and wrong? You people are welcome to make your comments. Anyone out there willing to contradict everything we just said? And I'm sure you can. I mean, if we had a mainstreamist over here, he would probably say something. Mitch, did you have something to say?
Yeah, I kind of, I've been doing a lot of reading on Glenn Borchardt's theories, and especially his last one that's like an ebook that you can purchase. But I believe in his, he believes in infinity in both directions, and he presents a lot of theories about, and I share his thoughts with this, that the ether is made out of very small particles, which would be essentially be like the atoms of our atoms. Like there's different levels of or I don't know what they call them, like ether 1, ether 2. Our ether 1 would be the atoms of our atoms, and our ether 2 would be the atoms of those atoms. And I guess what forms this bubble around the Earth, and he talks about it in this recent ebook, is the pressure gradient. He believes in the pushing theory of gravity, like most of us do. And what causes the ether bubble or the ether pressure is because the difference between the small amount of ether, the shadowing effect, the small amount of ether that doesn't go into the Earth on one side, and the amount of ether that's traveling towards the Earth on the other side creates the small pressure gradient, which gets larger. Just like the atmosphere, the pressure gradient gets larger the closer you get to the Earth. But he goes on to talk about a little bit more about I think what you also believe, and that why doesn't everything slow down, is because these ether particles are traveling all the time, and there's always, he likes to say, matter and motion are the only two things that exist. And things don't slow down because of the ether particles are constantly in motion, and they can be caused in motion as well as supplying the friction to slow down motion. I'm not sure if what I'm saying makes any sense. He can, Glenn can do a much better job, I'm sure. But I agree with them on a lot of these things.
All right. Yeah, that's one idea, that you have kind of like friction, but then you have everything's in motion. So you have like anti-friction. So if something's slowing you down, there's always something going to be accelerating you. And on the whole, those things balance out. So it may not necessarily be a net loss.
Right.
And the pushing form of gravity is very, very popular amongst the dissidents. I personally don't believe it, but that's certainly one of the major viewpoints out there. All right. Well, I think we have kind of taken this topic to the limit, which is detecting orbital mechanics with experiments. And so now, did anyone else have any new topics they would like to bring up? Today is an open forum. So today, Harry started us off with talking about this question about GPS, which came up in the email topics. So maybe Pal, maybe you have a topic you want discussed. Or maybe Bob. Okay, well, if no one's going to throw out any other topics, we did come up 2 weeks ago with Bill Lucas. Too bad he's not here. The list of things that any atomic theory would have to explain. And the first part of it, we were trying to explain the specific quantized spectra of atoms. And so a number of different models were presented. Bill Lucas's model depends heavily upon, say, ring-shaped electrons. And I presented my own theory of atoms, which state that space itself is quantized, and electrons can only move fixed distances away from the nucleuses. So that's what gives us the specific fixed spectra. But now the next topic was, why is it atoms like water is very common? Why is it that it forms like this, it's like 110 degree or something angle? Why does the hydrogens form that angle versus, say, just a straight configuration? Because you'd think that these hydrogens are probably trying to get away from each other, and the furthest they could get away from each other would be a straight line, right? So those hydrogens should be at 180 degrees to each other versus, 110 or close to 90, right? So does anybody have any thoughts about, based on mainstream where we have these atomic orbitals, how is it the hydrogen atoms can be constrained at that angle? Anybody have? Yes, go ahead. Why is that?
On that, and I did miss that weekend. I had some emergencies come up, and I'm really sorry I missed that, because I have some theories of my own regarding the spectra, but I have to explain a little bit about the theory before I can explain the angles.
Okay, go ahead.
I call the theory the astroatomic model, or I call the model of the atom the astroatomic model. And I actually have a website. I just started recently. There's not much on it, but it's astroatomicmodel.org. But basically, it's a model that it's can be thought of as a modified solar system model. And basically, I explain the spectrum of hydrogen. If anybody's done any research, there's a very close resemblance to the line spectra of hydrogen to the periods of the planets in our solar system. And basically, in this model, the AAM, I call it for short, astroatomic model, I say that our solar system resembles the hydrogen atom. That instead of the hydrogen atom having one electron, it has what one electron plane, one plane of electrons. And basically, what causes the spectrum, the hydrogen spectrum, and why it resembles the periods of our planets is because, let's say there's there's a wave of atoms, and let's say this wave of atoms is going through a sample of hydrogen. Well, the resonance, some of those waves will resonate with the period of the planets. And those waves, that particular frequency won't be transmitted through the sample because the planets are resonating with those particular frequencies, which are the lines in the line spectra of hydrogen. I'm not sure if I'm really explaining this good, but that's what creates the line spectra, is because we have holes in those frequencies that are where the planets are resonating with the frequency going through the sample. Now, the heavier atoms, so the hydrogen has just one plane of electrons, or I guess you could call them planetrons. Now, the heavier atoms have, instead of having one electron plane, have multiple electron planes. Like oxygen might have multiple electron planes because the nucleus, which is basically the stars, are rotating around each other in a way that forms angles. And that's why some atoms bond with other atoms, is because of the angles that these nuclei form when traveling in the nucleus. So I guess to answer this question of why the angle of 110 degrees is because the hydrogen atoms are attached to these oxygen atoms at the same angle that the oxygen nuclei are forming in the nucleus of the atoms, if that makes any sense.
Well, I'm having a really hard time grasping that, honestly. I mean, we've got this experimental data showing where the hydrogen atoms really are. And now you're talking about like a model, like a sun-centered planetary kind of model thing. And
Right.
I can see that, planets would orbit around the sun. But, we would then be talking about like there being a star outside of our sun and planetary system and another star like hydrogen, and they are somehow being bonded to our solar system. But once again, I don't see how you could get anything close to a 90-degree angle out of that system. I mean, what is it about the orbital system that constrains it? I mean, those
because in water you have to include the oxygen atom. So when they bond to the oxygen atom, they're bonding through the electron plane. For the hydrogen, it would be going in the same direction as one of the planes in oxygen. And the oxygen atom has like maybe 3 or 4 different planes at different electron planes that are going at different angles. So the hydrogen atom, its plane would coincide with one of those planes of the oxygen atom, and the other hydrogen atom would coincide with one of those different planes in the oxygen atom.
Okay, so I think I see the difference here. So in our solar system, all the planets are aligned on one plane, right? All the planets are basically in one plane. But you're saying that in this setup, there's going to be more than one plane. Let's say we put a plane at a 90-degree to the existing plane, right? So that will form like an X kind of pattern. And then your hydrogen would be on one of the planes, and then the other hydrogen would be on the other plane at about, say, 90 degrees, right?
Right.
Okay, so that is your conception on how that would happen. And do you get more detailed about, because if you look at what kind of things are possible to be formed, they typically might form, say, around an octahedron, I guess. So an octahedron would require, well, I suppose that could be described by just 2 intersecting planes, because you can get up to 6 things being attached to a single atom. Although I have seen up to 7, which is unusual.
How does the mainstream explain it?
But okay, so the way the mainstream explains it, I think it's called something called a VSPR or something. So you've probably seen these pictures of like electron orbitals. And these are kind of like if you took like balloons and you tied them together, right? So the bond that's in water would be a covalent bond, and so what they're doing is they're saying that the electron in the hydrogen is getting shared by a free electron shell in the oxygen, and that's what causes the primary bonding. And kind of like depending on how you tie your balloon animals together, you can get different angles of those clouds, and that kind of explains the atomic bonding. Now, I may be completely massively murdering the mainstream explanation here, but I think that may be close enough, not unless someone else is more familiar with that mainstream model. Does that sound close enough to people?
Well, I think you can always look it
Yes.
up on Wikipedia. It explains it has a little bit about the 140-degree angle, and I recall there was some emails a ways back. I think Bill Lucas was involved in that too, explaining how the 104-degree bonding occurred in the H2O molecule, and basically you have to take into construction of the molecule. it is explainable, and it's in Wikipedia does touch on it, and I'm sure there's a lot more references to exactly how the 104-degree angle comes out.
Well, I was looking at that like last week, and it just seemed like a whole lot of hand waving. It's like I didn't see a precise explanation for it. They're just saying that the hydrogens repel each other, and so that kind of pushes them apart from the 90-degree angle, and that may be true, but that seems to be kind of a hand waving thing. By the way, can you guys see my screen share here? I think I found Mitch's website here, astroatomicmodel.org is what it is. So, but my website, my bandwidth here is so slow, I can't seem to actually bring up any of the contents except for maybe the homepage. Not unless you haven't populated any of that stuff yet.
I haven't. I think if you go into core concepts, there might be a couple topics in there that I have a little information on.
Okay, but a lot of them, so you have an outline, but a lot of them are not filled out yet. So that's not my browser. That's if you go to home, you've got a pretty long explanation here of your basic concepts, I think.
Right.
So keep on working on that. When you finish filling that out, you can come back and give us a proper introduction to that, I think.
Oh, thanks. I'd like to do that.
But
Franklin, did you follow footnote number 54 in the Wikipedia explanation of H2O, where right next to 104 degree? You might find that that gives you more details.
No, I could try and look that up right now. Let's see here. Let's go to.
There's a footnote number 54 there that'll link you to more detailed.
Did you put something? Did you put something in the chat?
No, I didn't. It's just under Wikipedia under the water molecule.
Here, water
If you
molecule.
if you search down for
wiki. If you look at water, Wikipedia, let's see here. Did they mention anything about the particular bonding?
Properties of water, and then just look up and search for the word angle within the article, and you'll find 104 degrees, and then you'll find a footnote in there.
They're like that. I think I looked at that before, and it was all just kind of a bunch of hand waving. But let's see if we can find.
Yeah. So I mean, I'm just saying that's a reference you can look at. I don't know if we necessarily need to look at it now. Like I said, there was conversation in earlier emails, probably even maybe 4 or 5 months ago, about that 104 degree angle of H2O. And I think it kind of pertained. We got off onto it, and based on Bill Lucas's model, using the magnetic characteristics of rotating charges within the atom.
Well, this is, I think, generally still a difficult to explain phenomenon, because you can go and get the list of all of the possible compounds. Some of them do make linear compounds, like carbon dioxide is, let's say, linear, right? So why is it linear versus water? I mean, chemically, it's one atom with two other atoms attached to it. Why is that a different format, right?
Well, it's because the number of atoms that are in the electrons in the outer orbital more than anything, and how they have to be angled to share that orbital.
What does that mean, right?
Well, when you have an atom, when you have an electron in an orbital and actually have the charges in the orbital, if a charge is occupying one plane of orbit, that plane of orbit is already stressed by that charge. So putting a second charge in that plane or in that orbital distance, that since that
region of the field is already stressed by the existence of one charge, the alternate charge, an additional charge, is likely to go in a plane that is not stressed, because a stressed plane will basically slow down the energy level, or the amount of tension available within that plane
But why should there be planes? You know, the problem here is that if we go with, say, the mainstream kind of concept of what's going on here, so all of the protons are like stuck in a nucleus. You've got all these electrons flying around, and we have Mitch's idea that they're perhaps in different planes, but we just don't really see anything like that in the real world. We would think that if you got like there's 5 or 6 electrons flying around an atom, that they would be doing so randomly. They would crash into each other, or at the very least would be symmetrical.
Well, that's where you have to look at the charge as not a piece of mass, but as a field, as a wave moving around the center. It's a tension wave. It's a stress that moves around in the media. And if a media is stressed, then a wave is not going to travel through that media as fast as it is going to travel through an area that's not stressed. So since the electron charge has already, if it's orbiting around, if it's already passed through a specific area and that area is stressed, it's going to veer off and precess into a different plane of orbit. So if it's a single electron going around, like a hydrogen, like the hydrogen atom, and the hydrogen atoms typically don't come alone; they come in pairs, but because you had a hydrogen molecule. But if it's in a single atom, if you think about it, as it goes around, it puts stress on that circular and that plane of rotation, and so because it's stressed to the point of weakening the field, the tension will move faster in an area that's not stressed to that point. You understand? If you stretch.
Well, not really. I mean, it's still not explaining. Like, do you see my picture there? So that's a model of water.
That's a model. Yes.
Okay, and this comes from your standard organic chemistry set here.
Okay. All right.
And
all right, jump. You're jumping way ahead.
No, we're not jumping way ahead. This is the main question, which is, why is it we can model molecules pretty accurately, actually using this ball and stick kind of model here, right? This is a physical model, and just by I don't know that this is like a carbon, and then this is like an oxygen, and this is like a nitrogen, and the angles that you get are actually fairly correct. I mean, this is like a tinker toy thing, right? So fundamentally, you got to wonder why is it that we can describe molecules in this tinker toy like fashion, and this is actually fairly accurate. So
it's accurate as far as the angle goes.
And it may, in fact, be accurate to how it actually works. Do you think? Could it be that the reason why molecules form like this is because literally the atoms literally have sockets, and literally they bond at that angle, and literally there's something that's just physically like a tinker toy in there.
Absolutely. It could be something as ridiculous as that.
Yes, because actually that's the way I would actually propose that it actually works.
But it would be totally ridiculous.
Well, let's see if you think this is totally ridiculous. So this is my idea. So once again, my theory shoved upon you. You may choose to believe it or not. Okay, so my theory is that atoms actually look like this. Now, this is a rather large atom. I think this is radon. But you can see it's built.
I was just speaking about the rotational pattern of a single electron around a single nucleus.
Yes.
Now, if you
So
don't
I'm talking
if you
about.
don't, if we do not establish the fundamentals of a single electron around a single nucleus and what that means and how that works, we cannot build up to a complex device like you have there and understand how it works.
Sure, you
And
can.
so
Let's
if you
start.
want to just
Let's
start
start
with
with
the most
that.
if you
So
want to
this
start
is.
with the most complex device, we're done talking. We're done talking.
So let's just say we start. Let's start there. So this is a proton. This is an electron. Okay. So what's a hydrogen atom? It's this: electron, proton. That's it.
That's not an electron and that's not a proton. That's two little squares that you have put together. Those are
Yeah,
not electrons and protons.
this is how I modeled protons and electrons. I mean, that's fair. If this is a proton, this is an electron.
That's not a model of anything.
Yes, this is a model of
anything.
this is my model of hydrogen.
And it's not correct.
Just like this is a model of water. Do you disagree with this model of water?
Absolutely. Because
You
there's no
disagree with
motion
this
there.
model of water?
Absolutely.
Well, I think that
there's no motion in that whatsoever. There's nothing tying it together. It's made of plastic. It's not a model of anything. There's no energy in that.
okay, so you think that everyone who plays with this in organic chemistry is wrong?
I think they're idealizing it so they can understand how the bonding angles are working. But
Yes,
it's not
and that's
a model
what we're
of an
doing
atom.
here with the model. See, if you start with this, I mean, I'm just going to have to go on. If you don't understand my model, then I don't know.
Oh, go
But
on.
this is hydrogen and oxygen. Okay, now if you add another neutron, now neutron is just a positive negative charge. So this is deuterium. This is a positron electron with a neutron. The neutron is also represented by a positive and negative charge. And together, this is deuterium. Now if you take two deuterium and you fuse them together, you get this. This is helium. Now, we don't get helium is non-reactive. You don't get reactivity until you get to the next one with the lithium. So I've changed my model here so the white parts are the neutrons and the red parts are the protons and the red parts are electrons. Okay, so you've got this square block. Okay, so what's lithium? Okay, lithium is that you're just sticking on one more deuterium. Now this is unbalanced. You can see this has 3. You have a cube that's got 1 extra thing on it. Now, what happens, I say in molecular bonding, is that you've got another molecule out here. Let's say these are 2 lithium atoms, right? So I've modeled this so that you can see that this is the 3 pieces of lithium. That's why lithium has a atomic number of 3. And if you have 2 lithium atoms, then we have these checkerboard patterns here due to the charges. Now, these 2 checkerboards will attract each other, and they will bond together like this. And this will, in fact, form which would seem to be like another helium nucleus, because actually everything is trying to get to this helium configuration. So if you have an atom which has this spare piece on it, in order to get to its lowest energy configuration, it's going to want to bond with another one of these spare pieces. So fundamentally, this is why atoms join into molecules. It's not that there's a free electron flying around this lithium ion, which is covalently bonded with the other one. It's that there are literally docking ports, just like in these mechanical models here. If I were to model lithium, literally there would be, just like this, there would be one ball with one stick on it. And that's what my lithium atom represents. Now, as you build these things up, you just keep on adding things onto this. So you start getting atoms which look like So you just take the core, you keep on adding stuff on here. So this is actually what carbon would look like. See, and carbon has these 4 docking ports that are available. So you've got this central helium in here, and then you've got 4 ports that are on the side, just like the organic chemistry model. You've got a model that has 4 holes in it that you can stick things into. So same thing with my model. You've got an atom which you can literally stick 4 other atoms onto, right? So you can get methane, which is 4 hydrogen, or you can get carbon dioxide, where you would have two atoms in a linear fashion. Or, the carbon methane has 4 hydrogen, and they're kind of like bent down and bent up, and that just reflects the proclivity of the other hydrogen atoms to try and get away as far away from each other as possible. So in that way, I kind of like following along the mainstream explanation with that they're just trying to get as far away as possible. Now, for the specific case of oxygen, basically, the reason why it's at a 90-degree angle is because the atom looks like this, where it's got 2 free docking ports at basically a 90-degree angle, and just like the stick model, you can see the similarities here. This is why it's at a 90-degree angle, not at a 180-degree angle. In order to be a 180-degree angle, the oxygen atom would have to look, something like this. It would have to be straight, but it doesn't do that. Its docking ports are at 90 degrees when you work out the model. So that's my explanation for how to. Now, eventually, I freaked everyone out, especially about bringing out this particular model, which is the heavy atom. So like I said, this is like radon or something, and it's octahedral, but it does demonstrate all the possible binding areas for a molecule, which is only at the vertices. So you can have the bottom, the top, and around the 4 edges. So I would say you could get up to 6 atoms attached to any atom, and if you did have 6, it would be in the octahedral format, and that is in fact what these molecules look like when they have 6 other atoms attached to them. They exactly correspond to the octahedral. So what do people think of that? Is that crazy, or what do you think of that? I mean, that's a purely speculative theory.
So your model is largely geometrical?
Absolutely, totally geometrical. So my model, if you go to my website, I model every single atom and show how it matches up with this molecular pattern, this molecular shape pattern, right? You can see where the atoms have to combine in order to see the types of molecule shapes that we have. And and it actually drives what I think the shape is, because you can put, this is a bunch of Lego bricks. You can put this in like this particular set of Lego bricks, you could put it together in any format you wanted to. It doesn't have to look like this. This is kind of sparse, but it's the only one that really represents what you see as you go across the periodic table, right? Because in the periodic table, you get some odd things where as you go up in the number of atoms, you get fewer and fewer connections. Like when you go from like oxygen up to neon, every single time you add something on, it reduces the number of docking points available. So like carbon would start with 4, but as soon as you get the next one, that blocks off one of those ports, and then it blocks off another one of the ports, and it blocks it until you get like fluorine, which only has one, and it's highly reactive. But then when you add on one more, then you get neon, which is non-reactive, right? So, and then you explain that by you have these docking ports, and every single time you add something, you plug those docking ports, right? And that's why until you get to the Nobel elements, which is effectively all built out of helium nucleuses. That's the other thing they notice, is that all of the Nobel elements can be expressed as a combination of helium nucleuses, which are completely non-reactive. But
well, I think your geometrical explanations, they describe a lot about how the bonding occurs. I don't know if I agree with them altogether, but I think it's a good way to describe why the bonding occurs and the angles of the bonding.
Yeah, well, thank you. That's all I can hope for, which is generally speaking, try to explain this molecular bonding angle data. But it seems that we have come to the end of another exciting edition of the Science Chat. So we did start, I'm going to summarize a little bit today. So we did start off with a discussion about GPS and how is it we can measure the speed of the Earth through GPS. And we had discussed some things about why is it we cannot measure the 30-kilometer orbital speed of the Earth, but we can measure the 24-hour rotation of the Earth. And we discussed various ether models which can either explain or not explain these phenomenon. So I think a lot of us dissidents might prefer, at least I do, that the idea that there is an ether and that the ether is dragged along with the Earth, and that explains the 30-kilometer orbital speed, but that the Earth rotates within that bubble, so that explains the be able to detect the 24-hour rotation. Then we started to get back a little bit into atomic models, which is to try and explain, why is it that we can describe molecules, and why is it they have these angles, and why is it the organic chemistry set describes this pretty well. And so, we had the idea from Mitch about there being different planes, that there's a different plane, say, going around this way, a different plane going around this way, and that is what the atoms are actually attaching to. That's one thing, and we had his website, and then I explained my ideas, which is I think that atoms are physical conglomeration of protons and electrons, and that physical conglomeration actually drives the creation of docking points, which is very similar to what we see in the organic chemistry set. So if that's right, they'll give me a Nobel Prize someday. But otherwise, people will just continue to think I'm crazy. But that's what we do here at the Science Chat. We talk about anything, alternative models, and we try to explain the things that mainstream really can't explain, which is one of these things, which is atomic bonding angles. But that will do it for this week. Thank you. Let's see. Stop the conference here.